Okay, so the focus of this worksheet is going to be problem solving in geometry. The vast majority of what we're going to do on this worksheet is just work with formulas. There will come a point where we will bring back direct translation, where we have to assign variables to different values and then create an equation and go from there. But the first few problems we're going to look at are just going to be using formulas. With that said, I do want to remind you of a few things. There are a couple of definitions that you're going to need to know going into topic one. So topic one is problem solving using formulas for area and perimeter. The first definition I want to remind you of is that of a polygon. All right, when you're dealing with area and perimeter, oftentimes we'll talk about something called a polygon, and that is just a flat, enclosed figure made up of at least three sides. So think triangles, rectangles, squares, pentagons, hexagons, octagons, whatever. That's a polygon. Now, when we're talking about perimeter of a polygon, this is the distance around a polygon. And what you need to know about perimeter is measured in just linear units. So if you're going to measure the distance around something and you're measuring it in inches, your final answer is just going to be inches. You're just taking all of the inches for each side and adding them up. So measured in linear units. Now, area, on the other hand, measures the surface of a figure. So measures the surface of a polygon. So a polygon is like a two-dimensional figure. So we're just looking at the surface of that two-dimensional figure. So envision like a room, your living room, your bedroom, a classroom, whatever. When you're talking about the perimeter of that room, you're looking at just the sides, like how long is each wall, add it all up, okay? A lot of times rooms will have like a baseboard in them. If you can envision what a baseboard is, you just add up the length of all the baseboard. So if you're adding in feet, you're just going to get feet for one wall plus feet for the second wall, third wall, fourth wall, and so on. When you're dealing with the area, envision the flooring. So do you have carpet? Do you have wood floors? Do you have linoleum? Do you have tiles? All of the flooring represents the area. So it's the surface of that floor. So that's kind of the difference between perimeter and area. And what's really important is area is measured in square units. And I'll show you how this is with our first example that we're going to look at in just a bit. But imagine you're looking at the perimeter and you're measuring it in centimeters. You're just adding the length of centimeters, so linear centimeters. When you're dealing with area, in order to cover the surface of a two-dimensional figure, you have to use a two-dimensional figure to measure that. So we would look at a centimeter squared, or a square that literally measures a centimeter on each side. So how many of these 1 centimeter squared units will cover the surface of your figure, okay? So we're literally looking at a way to measure two-dimensionally versus just in one dimension, okay? And when we look at this first example, I'll kind of show you how that like squared thing comes to be, okay? So let's go ahead and look at our first example. So example one says solve each problem, include units with the answer. Okay, so we have a sailboat has a triangular sail with an area of 24 square feet. So you can see right there, we've got our area measured in square feet and has a base that is 4 feet long. Okay, find the height of the sail, use area. This is the formula for area of a triangle. Area equals 1/2 base times height. Now, just to make sure you all know, if you're dealing with a triangle, you have the base, and then perpendicular to your base, the highest point, that is the height. Okay, so we're going to take what we know, we're going to plug it into this formula, and then we're going to solve that. So we know the area is 24 square feet, okay? And that equals 1/2 times the base, which is just 4 feet, times the height, which we don't know, okay? So we want to simplify this. The right-hand side is just, or the left-hand side is just going to be 24 feet squared. The right-hand side, I can multiply 1/2 and 4. That's pretty easy. 1/2 times 4 is just 2. So I get 2 feet times the height. Now here's the issue. I need to get height all by itself, completely by itself, a single positive one height, okay? In order to do that, I have to undo the multiplication that is taking place. So I'm multiplying height by 2 feet. So I want to divide height, or divide the right-hand side by 2 feet. So if I do that to the right, I have to also do that to the left to maintain balance. So looking at the right-hand side, 2 feet divided by 2 feet, that just cancels. That just becomes 1. So 2 feet divided by 2 feet, 1 times h is h. And then on the left, we have 24 divided by 2, which is 12. But then if I have feet squared divided by feet, it kind of ends up just becoming feet. So imagine instead of writing feet squared as feet with like the exponent of 2, what if I wrote it as feet times feet? And then I can take feet squared and divide it by feet, which is feet times feet divided by feet. Well, one of those feet cancels, leaving 1 foot left behind. So the height is 12 feet. You have to be really careful with the units here with area, okay? As tricky as that may seem, it's important, okay? So understand how these units play out. Now, I'm going to erase what I just showed you with the feet so we can check our answer, okay? So let me erase this. And let's check. Now, the area we know is 1/2 times the base, which we said is 4 feet, times the height, which we now think is 12 feet. So let's check and make sure everything works out. We want to make sure that when we multiply this out, we get 24 square feet. Okay? Well, 1/2 times 4 is 2. 2 times 12 is 24. So when we look at the 1/2, the 4, and the 12, we do get 24. And then notice here we have feet times feet. If you take something and multiply it by itself, it just becomes squared. So we do end up with 24 feet squared. So we were able to check, and we can say now with confidence the height of this triangular sail is 12 feet. Okay, so just be careful with your units and try to really understand why we use square units with area, and then in just a minute you'll be able to see the linear units with perimeter. Okay, so part B, it says the perimeter of a picture frame. So picture frames for us are generally going to be rectangular, okay? So the perimeter of a rectangular picture frame, so again, you can plug in rectangular, is 36 inches. If the width is 4 inches, what is the length of the picture frame? And then it tells us to use perimeter equals 2 times the length plus 2 times the width. Okay, so we know what P is. That's 36. We don't know what the length of the picture frame is, so we're just going to leave the 2L, and then the width we know is 4, so we're going to take 2 times the width of 4, and then we're going to simplify this and see if we can solve, okay? So we've already learned how to solve. Let's put our skills to practice here. We need to isolate the term containing the variable, and in this case, the variable is the L. So what I'm going to do first is I'm going to simplify. I'm going to take care of that 2 times 4 really quick, and then we'll learn how to move, or not learn, but then we'll learn, or I keep saying learn, then we'll move the 4 times 2 to the other side of the equation, okay? So we keep the 36, we keep the 2L, and then I'm going to go ahead and just simplify the 2 times 4, which hopefully you know is 8. Now, our goal is to isolate the term that contains the variable. So we want to get the 2L alone. We need to move that plus 8. And hopefully you remember, excuse me, from previous videos, to move addition, we use subtraction. We're always undoing what has happened to the variable. This variable term has got 8 added to it. We need to move that. So we're going to subtract 8 from each side of the equation. Okay. So on the left-hand side, we get 36 minus 8, which is going to leave us with what, 28? And then on the right-hand side, we're just going to be left with 2L because 8 minus 8 is 0, and then 2L plus 0 is just 2L. Remember, we as mathematicians get lazy and we'll be like, oh, the 8's cancel. Just remember, 8 minus 8 is 0. That's why we can say it cancels. Now we're left with 28 equals 2L. So now what has happened to the L? It's been multiplied by 2. We need to undo that. So we undo multiplication with division. So we divide both sides of the equation by 2. Looking at the right-hand side of the equation, I get 2 divided by 2, which is just 1. So that leaves me with just one single L. And then the left-hand side of the equation, I get 28 divided by 2, which is 14. Okay, so let's see if we can double check and make sure this really works. So we're going to check. We want to see what the perimeter equals. Well, we have 2 times the length, which is 14 inches, plus 2 times the width, which we know was 4 inches. So 2 times 14 is 28 inches. 2 times 4 is 8 inches. And now we have 28 plus 8, which is 36. And we're basically combining like terms. So if you've got inches and you're adding more inches, your final answer is just inches. So we really do get that the perimeter of this picture frame is 36 inches. And most importantly, the length of the picture frame is 14 inches. So that answers the question here. Okay, so try to understand, just remember the formulas for area and perimeter, but try to understand why with perimeter it's linear units and area we would end up with square units.